Hi everyone, today we're going to use what we've learned about graphing lines and writing equations of lines to write linear models. So when we say a linear model, what we really mean is a linear model is the equation of a line that is used to represent a real world problem. So we're still going to be writing equations of lines, but this time instead of writing them from a graph, we're going to be writing them from word problems. So we're going to be taking the information in the problem and writing a linear equation that represents that problem. Now, just like we have been to this point, when we're writing the equations of lines, we're going to be using our slope-intercept form. So these equations are going to be in the form y equals mx plus b. So what we really need to talk through here is how we find the m and the b as we go through our word problem. So let's go ahead first and talk about how we're going to identify the m in our word problem. So we know that when we're talking about slope, that's our m in the equation. Now, in our word problem, we're going to know we've identified the slope when we're able to identify some sort of repeating value. And I think the best way to kind of explain this is to look at problem number 1. So if I look, it says a truck rental company rents a moving truck for 1 day by charging $29 plus 20 cents per mile. So if I'm reading that, I know I have to pay $29 once, but for every mile that I drive, they're going to charge me 20 cents. So that part is going to repeat over and over again. That's what we're talking about here. That would be my m in the word problem, this 20 cents. Because every time I drive a mile, they're going to repeat that charge of 20 cents. Now, the slope, my b, is different. Right? When we're talking about the y-intercept, that of course is our b in the equation. And as far as the word problem goes, we're going to know we found the y-intercept when we find something that only happens once. So it may be a one-time charge, or it may be worded as some sort of starting amount. So let's go ahead back to this problem. Again, we have our truck rental company. They're renting a moving truck for 1 day by charging $29. That $29, I'm only going to pay one time. So they're going to charge me the $29 once, and then the 20 cents every mile. That's my repeating part. So by using this, I've identified the m and the b, and that's going to help me put together my linear model. All right, so part A asks us to write a linear model that relates the cost, C, in dollars, of renting a truck to the number X of miles driven. So the first thing I want to do is kind of identify my variables here. So I know that C is equal to the cost in dollars. And they've also told me that X is the number of miles driven. Now, as I'm thinking through this, I know I have to fit this somehow into y equals mx plus b. I know in this form my x is my independent variable and my y is my dependent. So I have to go back to these variables and figure out which is which. In this case, I know the cost is going to depend on the number of miles that I drive. So in my case, my y, that's actually going to be the c in our in our problem. So I know that that cost is going to be equal to, we said m was the repeating thing that happened in our problem. So my m is going to be 0.20 times the number of miles driven. Then we need our y-intercept. We said that was the one-time charge, and in our problem we identified that as the 29. So the cost is equal to the 20 cents times each mile that I drive plus that $29 one-time charge. So that's going to be our linear model, and we're going to use that to answer some other questions about this situation. So the first problem asks me to find the cost of driving 110 miles. So let's take our model here. I have 0.20x plus 29. They're telling me here the number of miles, which I know that number of miles was our variable x. So what I'm going to do is I'm going to replace my x with the 110. So my cost, that's what I'm trying to find, is going to be 0.20 times the number of miles, which is 110 plus 29. And I'm just going to use my calculator to figure this out. So if I put this in here, you can see that I'm going to go 0.20 times 110, plus 29, and that's going to give me 51. Now I have to think of what my units are. If this was a total cost, let's see, total cost in dollars, then my answer should have appropriate units, and the cost is $51. Now, we're not asking you to do this here, but I want to tie it back briefly to our function notation. If I wanted to use function notation, I could say the cost of driving 110 miles, that was my input, is going to be $51. Again, we didn't ask for that here, but I think it's good to kind of bring that back because this gives me a little more information about what my input was and what my output was. Now, part C is a slightly different question. Now they're telling us here if you had $300 to spend, right? So that's actually going to be our C. That's talking about our cost. And they're asking us how far could you drive, right? They want to know what would that X be? What would the number of miles be? So if I again go back to my model, in this case, I'm replacing the C with 300, and I'm going to solve for the X. And we're just going to do that by using our solving techniques. So I'm going to subtract 29 first. I'm going to use my calculator here to help me out. So I get 271 equals 0.20x. To isolate the x, I'm going to divide by my 0.20, and I get x equals, let's see here, grab the calculator, put it over here, 271 divided by 0.20, wow, I get 1,355, and again, because we're measuring the units that we drive in miles, I'm going to make sure I have that in my answer as well. Okay, so that's how we're going to generate and then use a linear model. So we'll do one more, and then we'll leave the other examples for class when we're together. All right, I'm going to adjust the camera here so I can get this problem. All right, this problem says a chemist's salary was $35,000 in 1985, and it increased by $300 per year. So the first thing I need to figure out is what's going to be the repeating value and what's the one-time charge or the starting amount. So when I look here, it looks like our starting amount is going to be the $35,000, right? That's kind of where we began. And then every year, we know that salary is going to go up $300. So that's the repeating part of our equation. So we're asked to write a linear model that relates the salary. So I'm going to write my variables. I know S is the salary. And then it says to the number of years since 1985. Now it actually doesn't specify a variable here, so I'm going to call that X. So S is a salary and X is the number of years since 1985. Now I know my salary depends on how many years, right? It's been since 1985, so S is going to be my dependent variable. My M, my repeating piece, is going to be 300 times the number of years I've been working, and my starting point is the 35,000. So that's going to be my linear model. And again, just to make a note here, I'm going to say 300 was our repeating. And in this case, the 35,000 was that starting amount. Okay, so let me scooch my book up here. And now we're going to use our model to answer some questions. So this part B asks us to estimate the chemist's salary in 1991. Now, the important thing to know here, we defined X as the number of years since 1985. That means that this 1991 is going to be 6 years since 1985. We're not going to plug in the 91. We need to consider how many years it's been since 1985. So in this case, our X is going to be 6. So we're going to use our model, S equals 300X plus 35,000. Oops, I need one more zero. And we're going to plug in this 6 for our X value. So now I know that my salary is going to be 300 times 6 plus 35,000. And again, I'm going to go back to my calculator. Just let this do the work for me. So 300 times 6 plus 35,000. And I'm going to get 36,800. And we're talking about dollars, so I'm going to make sure to include those appropriate units in my problem. All right, now for our last part, it says if the chemist is earning $38,000, so I know this is their salary. Now it's asking us to estimate the year. So we have to figure out what X is. So again, we go back to our model. We know S is 300X plus 35,000. This problem is telling us that S is 38,000. And then we're going to solve for X. So the first thing I'm going to do is subtract my 35,000 from both sides. So that's going to give me 3,000 is equal to 300X. So last thing I need to do to isolate X is divide by 300. And then if we go back to our calculator, again, don't guess on these problems. We have 3,000 divided by 300. We're going to get X equal to 10. Now, here's where we have to be a little bit careful because we actually haven't answered the question yet. what we have is 10. So what we're really saying, remember X was the number of years since 1985. So if it's been 10 years since 1985, it means the year then is actually 1995. So we have to be a little bit careful that we go back and ask if our answer is reasonable. A year of 10 doesn't really make sense. We have to go back and add it to our starting year. All right, so we're going to stop there. That'll give us a couple of examples that we can talk through when we're back in class. So I will see you then. Thanks.